Obviously, the word is emphasis. I use that all the time.
I don't know. I'll tell. Go.
Like the stress, and I don't even know. It's not our focus.
How do you say humble?
Be humble.
Humble.
Be humble.
So you say the hum first.
But I do, but I don't. There's a difference between be humble.
He's putting B and hum.
Yeah, he's pushing them together, right? Like he's changing it. That's we're agreed. It sounds like we're arguing, but we're not. Anywho, Kendrick Lamar, we'll have to write him a letter and ask if he says it weird or not. Here's our problem. We are using example 8, which you had to read part of example 8 to even be able to do this problem. So we have a return flight for a plane that takes 4 hours and 6 minutes, and we have to set up all this other information. So you guys hopefully have this set up. Here's example on page 482, and I need to know what do I write and where and why and how. So give me some equations. Let's talk about them. Okay, so we're just going to make a little note here. I'm going to write down a few of these. Distance, which this would be displacement in a physics class, but distance is equal to 2,000 miles. Okay? What else do I know? Okay, one direction. What's the time take? 4 hours, 24 minutes. Okay, other way. Do they give me the time as well? 3 hours, 45? I don't know. I thought I heard it. 4 hours, 6 minutes. That's a better way to word it. But I have 2 flights happening. And what do we have to find? Find the speed of what? So speed of plane, and I'm just writing this down in like hopefully a nicer organized way, and speed of wind. Okay, now they set up the problem for you on the first time, and now that I'm back in the mode of pre-calc stuff, pick this problem so you had to read through their problem to set it up. And hopefully that helps kind of work stuff out. You guys used their variables, right? I assume you did. When I do these, I don't typically. I use S for the speed of the plane. I use W for the speed of the wind. I don't know that they did the same thing here, but that's all right. Let's use their variables, or do we want to make our own? You guys all used theirs. Let's use theirs. What are my variables? R1 is what? Okay, thank you, Sean. R1 is speed of the plane, which means R2 must be speed of the wind. Okay. Now, to set this problem up, if we need a speed, how is speed related to a distance? They also give me time, just throwing that out there. If I wanted to calculate a speed of something, I need to measure some stuff, right? What do I need to measure? Okay, so this is pretty common these days. 30 seconds with your neighbors. I want you to find me a way to figure out how do you find speed of something. Speed is calculated by doing what? Rate and time. So careful with that. I think speed is rate. How fast we travel is called speed. That's the rate of which we change position. That's the same thing. Distance over what? Okay, so we have distance over time, and I'm going to use this to my advantage. Cool. They give us some equations, or we have to write our own? They give us some equations. All right, so they write out some stuff here, and I'm just looking at it. When you're flying a plane, if you're flying a plane at 100 miles per hour, so it's like a little Cessna or something, and the wind is blowing 100 miles per hour at you, so you have a headwind, do you move? Your effective ground speed would be 0, right? Because the air that you're traveling, like they're just counteracting. Okay, which one of these is with the wind? Like we have a tailwind, so they go faster. Which trip here is with the wind? One way or other way? Why other? Okay, so speed all over, like everything, this is R1 plus R2. It's going faster because the wind, it's a tailwind, so it's pushing the plane through the air. And then this right here is a longer trip, which means R1 is a plane. We must subtract the wind. So that's where they get those numbers from, if you didn't catch that. Now, what on earth do? We need a system. We need two things, right? So we have two unknowns, means we need how many variables? Two. There's one more part about this problem that I would change that I assume they did, but I'm not just reading theirs. We're working it out, and I guarantee we do something similar. Something weird about this time. Like, it's not really that weird when you think about a plane flight, but when you think about the math of it, it gets ugly. Any ideas? Do you love it when you mix units? So we could make it minutes over 60. I'm fine with that. We could change it all to hours. We could change it all to minutes. I don't care which way we go. We're going to have to do one of them, though. Probably hours, is my guess. Okay, so let's start writing out equations then. We're trying to set up this system. We know the speed of the plane here. Cool. So one way, I know the speed. This is my speed of one direction, right? R1 minus R2 and R1 plus R2. In either case, how far do they travel? That's right. It's 2,000 miles, I think. Be a quick flight otherwise. Cool. Well, let's write it out. Do you want me to rearrange the equation, or do you just want to use this one? Do you want fractions or no fractions? Okay, so what would you do? I'm just going to use S, or I'll use R for speed, since that's what they used. Equals distance over time, d over t. Make it not fractions. Cool. Distance equals rate times time. Cool. Let's use this. Either situation, what's the distance? Baller. So let's go ahead and write our first one. I know that a distance of 2,000 miles takes some rate, which I don't care which one we go with first. This is return instead of other. So we'll go first trip first. R1 minus R2, that's how fast we go. And let's commit to time here. 4 hours, 24 minutes. Now, people naturally want to call this 4.24. That only works in Holloway time, as I presented either in this class or physics, with 100 seconds and minutes and hours and stuff. It doesn't work here. But I do know that 6 goes into 60 minutes really nicely. Everybody agree with that? 6 minutes is 0.1 of an hour. 24 minutes is 4 6-minute times. That means 4/10. I'm just going to use the time here, 4 hours and 4/10, or 4.4. And I'll put hours here in case it's tough to follow. Are you guys cool with that? 4.4 hours, 4 plus 24/60. Okay, what's my other equation need to read? 2,000. We're on the same distance. What's the new speed, though? R1 plus R2. And then this time, I guess we've already, this isn't the focus. What's the time? 4.1 hours. Okay. And I won't even write the hours there. Now what? And we're going to blast through it now, because this is the hardest part by far. What do you want to do, JV? Okay, I'm fine with that. We have to be really careful first. I can't just add straight down, because what happens before addition? Division or multiplication, right? Either one of those. Any multiplications just begging to be done real quick? I think so. Can we distribute? Cool, let's do that. Awesome. I'm going to move it this way and then I'll work downward. No, I lied. I'll do it right here. Nope. Cool. Okay, 2,000 equals 4.4 R1 minus 4.4 R2. Sweet. And then here, I believe we're just going to wind up with this guy, which is 2,000 equals 4.1 R1 plus 4.1 R2. Is everybody on board here? Okay, did we do the same thing? I haven't even looked at your book yet. I don't know. I haven't looked. Oh, they kept it fractions. Ugly. Cool. Well, what do you want to do? You could use substitution. Eliminate. What do you want to eliminate? R2? That's what I would go with. Now, this can be a hard question depending. And looking at your book, did you guys use the example to like follow it through directly? Okay. I'm going to do something, it's going to look similar, but I'm going to do it my way instead. If you're cool with that. You want to eliminate R2. I need to multiply both equations in, right? Or, nope, I lied. We'll eliminate both and we'll multiply stuff. Well, what do you want to multiply by? Or if we can agree that we're not going to make silly mistakes with it, I'm okay if we divide by stuff as well. What did you guys use? What's your next step? I can't get a feel for if people just don't know or if it's just quiet. I can't tell. I think you had to do something similar, didn't you?
Solve for one of them.
So speed of the plane, speed of the plane. So they say 2,000 equals this and 2,000 equals this, and there's their times, right? How did they get equation 1? The 5,000 equals 11 R1. They changed the fractions, right? Okay. So I just didn't. We just stuck with decimals. Now, here's what I would suggest. I don't care if it's the least common multiple, which language-wise, just to be clear, like 4.4 and 4.1, guarantee they both go into a number. I know that there's an easy number to get. I just multiply the top one by 4.1, and I multiply the bottom one by 4.4. Alternatively, I don't like this method, especially in earlier classes, because this is pretty common, leads to algebra mistakes. But if I take this, can I multiply by 1/4 or 1 out of 4.4? And I'm actually just going to call this divide by 4.4. Why would I do this instead? R2 is going to have a coefficient of 1. We can do this, or we can multiply by 4.4 and 4.1 to guarantee we get the same one there. Division or multiply? Okay, I'll divide. Somebody grab a calculator then. I need you to tell me, I'll do the second half of it. I don't know what 2,000 divided by 4.4 is. 500, 400 something. 454.54? Somebody second that? Okay, cool. Equals R1 minus R2? Easy. Cool. This one, what should we divide by? $4.1. So I'm going to ask somebody the same thing. I need 2,000 divided by 4.1. Bit closer to 500. 0.8? Exactly 0.8? 8. What's the number after 0? So 80. Okay. Equals R1 plus R2. Now, it looks different because we switched to decimals, but we're doing the exact same thing your book does. Exact same thing. Cool. Why is this just so awesome currently? Oh, my R2s. They gone. Somebody with a calculator, I need you one more time for me. We get 2R1 on the right side. I do not know what this turns to be, though. What is it? 932?
942.
Cool. Divided by 2. 471.17. Okay. The second we get this, remember R was a speed. And we have miles and hours. What should the unit be here? And I'm cool with MPH because it's so common. Miles divided by hours. Miles per hour. Cool. I always get bugged by one little thing. They word this problem as an airplane. I don't think you're going to find an airplane. And maybe my language is bad. When I think of airplane, I think of propellers. It's going to be pretty hard to find an airplane that you would ever get on that flies at 471 miles per hour.
What do you call a passenger plane?
A jet?
Every time.
If it has jet engines, yeah.
Wait, but when you tell someone like, I gotta go get on my jet.
I get on like 2 planes a year, and
Yeah.
they get on planes here.
But
I say I gotta catch my flight is what I say realistically. Yeah. All right. Cool. Now the benefit that I like about this one and why this is so nice is these equations. Remember, everything on this line, everything's everything here is equivalent. All 4 of those equations, which means if I want to find R1, I could plug in. Sorry, if I want to find R2, I could plug in R1 here or here, and it works just fine. But it's probably a little easier if we use either of these. I don't care which one. Somebody already has the answer. Plugging into either this equation or this equation or this equation or this equation, I would do this one. Find me R2. Somebody already has it, I guarantee it. Let's see. 16.63. Okay. All right, so we have all these values. Now I need to see what the question's really asking. Just for the record, I faked that. I have the number written right here. I knew what it was. Cool. The actual question. Find the airspeed of the plane and the speed of the wind, assuming that they both remain constant. The plane, and I'm going to change this now. The jet flies with, or at a speed, I'm just going to say at, I'm going to call it 471 miles per hour. Now, this is a speed with or without the wind? Without. I'm going to say in still air. Without any wind, this is the speed of your plane. We done. Oh, just kidding. The wind. Sorry. Blows parallel to the plane at, how hard is that wind blowing? I also have an issue with this.
I think it would be blowing a lot harder.
Oh my gosh, it would be blowing so much harder unless this plane is flying at 500 miles. Oh, got me good. Unless this fighter plane maybe could do this. Unless they're flying like 10 meters above the ground and just being the most dangerous, foolish pilot ever, the wind is going to be so much stronger than 16 miles per hour. Like the winds when you're flying, they're like 90 to 200. They're so fast up in the jet stream. Cool.
What? I was trying to say it without you hearing me. What is that after blows?
The wind blows parallel to the plane. Cool. All right. Systems of equations. We hit pretty hard, pretty quick. Do they feel all right? Okay. I'm going to give you guys some time to work on stuff today. I did not make you a worksheet, though, just so you know. So you're going to have to draw problems from... Ooh. Let me find these. We're going to get good ones. Did you guys like matrices last year? Was that a no? Con's pretty good. I don't know if it's not always Saul that does it. Okay. We're going to try something different. Okay, just so you know, we are in section 2 we just finished. We are going to look at systems of 3 equations and 3 variables next, using this fancy thing by the name of a guy called Frederick Gauss, which I think we spoke about him. I'm going to give you problems with the following kind of rules and understanding. I'm going to give you more problems than I think you really need to do. That might not be true for everybody. I'm going to say on page. So I will take this tomorrow just because I want to see. Homework, page 529 is where you'll find it.
Thanks for letting us know you're going to take it.
Yep. Until everybody, like, we were doing pretty good until recently. I usually just always assume I'm going to take homework every day. Probably will. Okay, page 529. I want you guys to do the following problems. Let's say we get 1 through 9. 19 through 22. 23 through 28. That could have been 19 through 28. That's my bad. I know it seems crazy, but I promise it's not as crazy as it seems. I'm 29 through 32. Okay.
Oh my god.
So check it out. We have 4 groups, and I could have split this up. Do you guys have these written the same way as I did? Good, because I want you to. For each section, I'm going to trust you this time, and you're going to demonstrate that you're being truthful with this, because I'm going to give you a small quiz tomorrow with 1 substitution problem and 1 elimination problem. They might be word problems, just throwing it out there, but 1 of each. So, here's the rule. As many from each section, or each group rather, as you, as an individual learner, need. The bare minimum, if you're sitting there going, nope, I don't need to do any of them, got them, at least 1 from each. If that's enough for you to convince yourself that you're going to do well on a quiz with no note card or anything tomorrow, just to demonstrate this, I'm good with it. If you need to do 2 from each, I'm good with it. If you need to do all of them, still good with it, but that's going to be a terrible night. You should talk to me if you feel like you're going to do all of them. We should do a couple together. Cool. The floor is yours.
You said,
Riley, if you didn't catch that, you owe me, after you guys get the hardware, a quiz consisting of 1 elimination problem and 1 substitution problem. Cool.